Gantt charts are traditional management aids used to schedule projects. They may be simple schedules that you develop on graph paper or complex and sophisticated versions that you create with computer software. You construct a Gantt chart by separating a horizontal axis into equal increments, hours, days, weeks, or months, and by using a vertical axis to list project tasks. Give names and numbers if necessary to project tasks on the left side of your chart as rows and dates at the top of your chart as columns. Use progress bars and milestones to exercise control. In this example, I identified progress bars by filling in bars underneath the solid black bars with slanted lines. I also added an M that you can barely see at the end of February to signify a milestone. Milestones are important because they are usually on your project's critical path. When you don't meet milestone dates, your entire project schedule suffers. Let's spend a bit of time discussing how to construct a Gantt chart. To get started, make sure to use a WBS to identify all tasks. Please keep in mind that your WBS doesn't sequence tasks. This is a job for your schedule. Follow these steps. First, identify project activities in order of their occurrence on the left side of your project form. While I can use a blank sheet of paper and a ruler, try to use spreadsheet software or even one of the popular project management software packages. Number two is to develop estimates for each activity. This can be a little bit tricky. You may have some excellent historical estimates you can rely on, or you may not have reliable data. To develop the best estimates, work with your project team. Number three, create time periods across the top of your page that represent the appropriate periods of time. Number four, for each activity, indicate start and finish times by creating task bars and by highlighting across each row. Number five, assign milestones. Number six, share your Gantt chart with all key stakeholders. Ask for comments and if necessary, make revisions. Number seven, monitor your project and create project bars. So on this slide, you can see an example of a Gantt chart that I constructed following these 7 steps. The project should take 28 days. If you review this chart for a few moments, you may see some limitations, such as the Gantt chart does not easily reveal a project's critical path. The critical path identifies the longest lead time sequence of events. While it is straightforward to determine the critical path for a project with a few tasks, you encounter much difficulty recognizing the critical path for a large project. Also, Gantt charts do not clearly identify a behind schedule condition. It's difficult to determine the effect of your total project for a behind schedule activity. This is because of a lack of clear interdependencies of project activities. Imagine a Gantt chart with many hundreds of activities. If you try to understand how one activity impacts another and your overall project, it becomes very confusing. In the final analysis, Gantt charts are great for small projects and for making summarized presentations to management and customers. But for larger, more sophisticated projects, use network scheduling. Networks are not unique to project management. Think about computer networks and networks of various things, including people. Since a project is represented by a series of interrelated activities, the network concept is perfect to define a project. Today, project management professionals use the terms CPM for the critical path method and PERT for program evaluation review technique interchangeably to describe network scheduling methods. I want to share one method with you today, activity on node, also abbreviated AON. But before we work on an example, we need to discuss a few key network scheduling principles. Make sure you understand and apply these key principles. First is earliest start. This is the earliest an activity can begin based on its relationship to its predecessor's duration. Latest start. This is the latest an activity can begin and still satisfy requirements set forth by successor activities. Earliest finish. Based on the relationship with a predecessor, this is the earliest an activity can be completed. Latest finish. Based on the relationship with a successor, this is the latest an activity can be completed. Float time. This is the amount of free time, also called slack time, an activity has without impacting the due date of a project. Forward pass. This is a technique that works forwards, starting with the first node in the network to determine earliest start and finish times. And then a backward pass. This is a technique that works backwards, starting with the last node in the network to determine latest start and finish times. These terms may not mean much to you now, but hopefully they will once you review an example. Here is an example for a fictitious company, the PDR television company. You could read the background information, but it has to do with a new project to make a 6-dimensional or 6D television. So the first thing that you need to do is you come up with a WBS that's not identified here, but you could do that offline. And what you do is you identify the list of tasks, their predecessors if they have any, and also their time duration. These three images identify the various steps for your network schedule. The upper left one combines two steps where you created the network diagram and you've also input the project task time durations. And this comes off of the information that you saw on the previous slide. The next step to the right is a result of the forward pass that takes place. And what you can see now are the earliest start and earliest finish dates for each of the tasks in that project. And then at the bottom, you see the result of the backward pass, where now you're able to come up with the latest start and latest finish. And you can see that the total duration of this project is 57 days. The final slide in our lecture shows the key results of our network schedule. So as indicated, some tasks have 0 float time and some have float. You'll find that the tasks that are on the critical path, which is the longest path for the project, do not have float time. However, we find that there's 4 tasks that do have float time, and you can find what the float is by using the latest finish and the earliest finish, or the latest start and the earliest start. And again, at the bottom, you can see the critical path. It's the longest path, represented by A, B, D, G, I, J, K. Now, if you have difficulty following this information, there are 2 videos that I have identified for you in D2L, and I highly encourage you to review those videos because they go through this information in more depth, and you'll have another opportunity to take a look at how to come up with a network schedule, which is very important. So that concludes our lecture for today. I hope you are doing well, and if you have any questions, you can send me an email, and I will do my best to help you. Take care.